Welcome to Data Brew by Databricks with Denny and Brooke. The series allows us to explore the various topics in the data and AI community. And whether we're talking about data engineering or data science, we interview subject matter experts to dive deeper in these topics while we're enjoying our morning brew. My name is Denny Lee. I'm a principal developer advocate and one half of Data Brew.
Hello, my name is Brooke Wenig, and I'm the director of our machine learning practice and the other half of Data Brew. And today we are thrilled to have Brandon Cui, a research scientist with Mosaic ML and Databricks, on our podcast to chat about reward models.
Hey guys. Yeah, Brandon Cui, right now research scientist at Databricks, right now leading the RLHF post-training, a lot of the post-training efforts here. Really excited to be here, guys.
Thank you, Brandon. So I know everybody's talking about RLHF, but before diving into that, could we just take a step back, like 30,000 foot view, like what is a reward model and why should people care?
Totally. Yeah, so for the 30,000 view for reward models, basically what they're very, very good at is having the ability to score image model generations. And so you can basically assess the quality of all the generations. That's on the either are they very helpful, are they very harmful, just this very core capability of what is this generation doing, and does it fit my needs, basically. That's what a lot of these large labs are doing. That's what we here at Databricks are also using them for as well.
And so when you think about reward models, how do you train one? Like, are there certain use cases where you should absolutely consider using a reward model?
Yeah, so at a very high level, how a reward model is trained is through pairwise preferences. And so at a very high level, this is kind of what you do is for every prompt, you'll have two responses. And you say which one is better, either A or B. This is also kind of implicit in some of the OpenAI interfaces you kind of see. Every now and then, if they're kind of unsure of which response to show a user, they'll actually kind of have this UI that pops up and you'll see two generations. It's not clear if they actually use this data to train things, but it's just one nice visual way to represent, hey, this is kind of the type of data that you expect for a reward model. Then from there, you just get a lot of preference data, and you kind of train this reward model that will say, hey, score the chosen things higher. So the generations that are either more helpful, will satisfy your criterion better, will either flag safe responses or unwanted responses as rejected. And basically, you now have this thing that will be able to say, hey, over this entire generation, what is good or what is bad, basically. This is the most naive sense of a reward model. There's more complexities here, but at the simplest level, this is what you should kind of use for a reward model for.
So I'm curious then, why actually go down this path of a reward model, right? I mean, why not just simply say, well, because the feedback was, option A versus option B, right? And then you go down. Why bother adding a reward model to this? I'm presuming it improves things, but I guess try to understand that context.
Yeah, so I think going down this path is from a human perspective. This is the easiest way to kind of get data. So usually when you're in this post-training stage, you have this, let's say, some base language model that was trained on a lot of internet scale data, but now you want to make it useful. The usefulness is you want the language model to answer questions, you want it to write code for you want it to extract data for you, write SQL for you for Databricks people is a very large use case. This is kind of what a lot of the post-training and RLHF stuff does. And then what happens is usually you want to kind of kickstart this process with instruction fine-tuning data. This is what a lot of the fine-tuning services offer. So Databricks, we kind of offer this service and it says, hey, if you give us prompt response pairs, you say, here's your prompt, the model should respond with this response. That's what fine-tuning does. The issue with this kind of data is it's usually pretty hard to collect. You either need a human sitting kind of behind the computer to label it for you, to generate it. Usually it's very, very intensive to collect. And so getting this preference data is much simpler than just always getting this instruction fine-tuning data. So usually it's like 5-10x cheaper to collect this type of data, especially from just a human user perspective, basically. And so with this, then also you can collect this preference data and create reward models, which would then be used to be able to filter out all this fine-tuning data as you go. And so you can then just say, I only want to train the highest quality samples. I only use the highest quality generations, stuff like that. So kind of, I guess, the 2 points to drive home here are, one, there's a lot of simplicity to getting preference data. It's much easier to say, from a human perspective, what is better, A or B? You don't have to look for all these little nuances. You don't have to look for all these little things, and you don't have to generate the data yourself. You already have the model being able to generate it. So that's kind of the core principle here around, hey, reward modeling is actually like this very nice, simpler in some ways way to get data and to use it to rank and generate, to rank data basically.
What's actually required for RLHF then? RLHF, excuse me. um, I'm guessing that you still need a human labor, or just because that's what you called out, what the problems. But what are the other aspects that you need in order to do RLHF correctly?
Yeah, I think for RLHF, basically with a human labeler, you then implicitly will be able to create this reward model. You have the human label say, hey, here's your reward model, is you now can rank and order data effectively. Then you really only need a set of prompts in the most simple sense of what you want to optimize for. So if you want to say, hey, I want to just this model to be really good at extraction tasks, you just need a set of prompts to say, hey, I want to do extraction stuff. Or if you want to say, hey, I want this thing to be really good at storytelling for kids, just basically a lot of prompts that say, hey, here's write a story about a princess and a dragon, or a simple Harry Potter story, something like this, right? And so from there, just you need the prompts, and then you can use the reward model to essentially drive a lot of the data filtering and a lot of the processes behind this core RLHF stuff, basically.
Going back to your point earlier about it's much easier to collect preference data than it is to ask humans to actually generate like prompt response pairs for instruction fine tuning. Playing devil's advocate, why wouldn't you just take the preference data, like human says like response A is better than response B, and treat that as a prompt response pair for instruction fine tuning? Why do a reward model with that as opposed to just treating the generator response as further input for instruction fine tuning?
Yeah, so I think you definitely can do this, right? So this is at a high level. You could you can first basically say the first step of the process is to run IFT with your chosen response. But then let's say you want to generalize this to a new set of prompts. Let's say you were wanting to write a lot of kid stories. You have this set of prompts and response pairs from your humans. But then you want to say, let's make these stories more complicated. Let's now write them for, let's say, young adults. That means you're kind of off distribution, but that means you can also still use this reward model to kind of label new generations from now your new language model. So you would basically say, here's now your base language model, fine tune them with your chosen proper response pairs. And then now you want to say, hey, I'm still in this distribution of storytelling. Let's now shift it to young adult writing. You would then take your set of young adult prompts, have your now language model generate a lot of data on this, and then you could have your reward model basically filter out all the samples, say, these are the best ones for young adults. You might have some distribution mismatch. You might need to go back to your human and get new preference data, update your reward model to say, hey, now I'm really good at, now this is what the kind of preferences for a young adult novel would look like. But in general, like in a very loose sense, you could kind of, this is a little hand wavy, of course, say, hey, this reward model is pretty good at ranking storytelling data. Now let's use it to this. Now let's shift the distribution slightly to make it a little harder and move on, basically. So again, you can use this. It's not. I'm not saying necessarily like this is the only thing you use it for. You can't just use it. You don't need to just use it for a word model, but you can use this data in other ways, basically, in very clever and creative ways. Does that make sense?
Yeah, that definitely makes sense. And I guess the other thing I'm still trying to wrap my mind around is when we talk about reward models, people think of that as synonymous with RLHF. Is that just because it's the most popular reward model out there?
Yeah, so I think the RLHF process really kind of kicked off a lot of the ChatGPT stuff. So that's where kind of I think reward models have been used a lot in the context of academia and a lot of open source stuff. But I think in general, even if you want to just do pure instruction fine tuning, as I kind of said, if you just have this massive prompt set and you want to fine tune on only the highest generations, you can kind of do this thing where you say, hey, maybe some of these prompts are not great. Maybe they weren't actually really good for storytelling, or they were either too specific, had too many constraints. Maybe they weren't constrained enough, something like that, basically. Or in the extraction case, maybe the extraction task was too vague. Maybe just the data is malformatted. in some ways, the reward model can kind of maybe implicitly capture the generation side of things and say, okay, this generation actually was, let's say, missing a JSON closure. The JSON is invalid. Again, there's more heuristic ways, more direct ways you can do this, but implicitly the reward model acts as kind of this very general verifier for the quality of data. So what happens is, again, you can consider this under the umbrella of RLHF, of just kind of filtering data. But again, if you wanted to say, hey, here's my prompt set, here are all the generations I have for my model, you can kind of fold this in the reward model to just filter all this data to say, hey, these are the really good generations. Let's fine tune our model on these generations. And that will probably result in a higher quality model than if you were to basically train on the entire set of generations that are of varying qualities, basically.
This is really cool because one of the things that at least like newbie me was always thinking RLHF was really only useful for safety per se, but it seems like it's actually useful for pretty much improving things in general, like improving reasoning, math, coding, things of that nature. I'm just curious, is my new understanding correct, or am I missing something here? Sorry.
No, totally. I think a lot of the ambiguity around RLHF was for safety, right? So I think this may have come up a lot where, again, OpenAI, if you send it if you ask it an unsafe response or unflattering question, it'll be like, hey, I can't respond to that. And this is partially in the RLHF process, but also RLHF has the ability to apply to coding, to math. Again, you can train reward models based on these large code traces. There's definitely academic literature in this. In a similar vein, you can train reward models on math traces as well. So this is a lot of the kind of work that OpenAI has been doing, Google DeepMind has been doing. A lot of the large labs are kind of heading this direction, using RLHF as a tool to improve reasoning, to improve math, to improve basically this understanding of data overall, right? Because at some point for any enterprise, if you say, hey, here's my corpus of documents, I want to kind of reason about this data in a multi-question answering setting, I want to do this very hard analysis that you should hire an analyst for. That actually requires a lot of nuance and a lot of understanding. And so this is kind of where reward models can shine as well, is on understanding kind of how to improve the step-by-step level reasoning capabilities and generations of models overall. That's kind of a very high-level overview of how I'm thinking about reward models, and we're thinking about it internally at Databricks as well, of just understanding data and giving your companies the ability to have intelligence about their data overall.
So it totally makes sense that like all of the benefits that you've outlined well beyond just safety. And you had mentioned that it's a lot of the large labs that are doing research into this. We're internally doing research into this. From the enterprise customer side, at what point should they be considering this? Because, correct me if I'm wrong, it's not a light undertaking to set up a reward model. So just curious when people should really think about, like, is it really worth the effort invested to build one?
Yeah, I think this is a bit of an open question, but again, if you have the resources and you want to do this from scratch, that takes quite a bit of effort. But also, there's this kind of general thing that we're seeing a little bit where reward models are pretty generalizable. So again, because you have reward models, basically, you start from this very large pre-trained language model. You then train it on, usually do this in a very general manner, where you say, hey, here's all my storytelling tasks, here's all my data analysis tasks, here's all the extraction tasks, and you train this general model to be very, very good at a lot of tasks. From there, you get your preference data on your reward model, to basically evaluate the ability to do extraction, classification, general reasoning. This kind of generalization means that for a generic enterprise NLP task, you will probably fall into one of these buckets overall. And so as at Databricks, as we build these reward models and make them more widely available to customers, it should be a lower lift for a customer to come with their data and say, hey, can you use your reward model on our task for extraction? Can you use your reward model on our task for data understanding, basically? And that's kind of where we're looking at is, hey, we will get you a very good starting point, and then you can provide us a little more context, maybe a little more promptability, a little more data, something that can help boost the context for our reward models to make it better on your data on your task. But the general notion is, hey, these models have been trained on just so much stuff. They're very, very general. They should be approximately okay at your task in a very, again, very hand-wavy manner. So, but a little bit hand-wavy, but um, they're generically just so good at these things that on on kind of this enterprise task of reasoning, extracting data, understanding what you're trying to do, they will have some signal there. And just basically, we bring that to the table and you bring a little more enterprise knowledge, a little more data to us, and we can help you get started basically. So there's kind of, that's the perspective of like, if you want to start from scratch, it's a little tougher, but our job here is to try to make it easy for you to use your word models overall.
So this invariably leads me to ask the question. So, for example, when we first started talking about large language models, first it was foundation models, and then we recognized, no, we're going to build these base models and Llama, Phi, whatever else as the current set of base models. So then what you're saying is that, in essence, there's a base set of reward models as well now, where basically we can start off with. So that way you in essence, fine-tune the reward model to fine-tune the large language model, right? In essence, right? Am my analogy is correct, I guess, the way I would phrase it?
Yeah, exactly right. So you would basically what we bring to the table is we have this generic reward model that's like pretty good across this very generic set of tasks. And then you could fine tune it on your own preference data. There's different strategies that look into kind of, hey, can you add in actual natural language into this reward model that says, hey, you look for these very specific things. And that's kind of what the enterprises can bring. So it's again, lower left and preference data, just the promptability of a reward model, kind of looking into can reward models provide critiques to these outputs, and could you actually use user input critiques as well? So for example, it'd be, hey, make sure, let's not talk about competitors, for example. That's something you could augment the reward model with as a user benefit, where again, this is open area of research, so it's just a hypothetical a little bit, but like that's what you
Yeah.
kind of bring to the table. So you'd fine tune kind of prompt DSPy-esque optimization processes on these reward models to fit it to your enterprise data and your enterprise task.
Does that mean there's an implication that you could also utilize multiple reward models at the same time to basically help with this process?
Yeah, exactly. So one thing you could easily do is say, hey, here's my reward model for safety. The safety is don't talk about my competitors, don't add unsavory responses, stuff like that. And then there's the kind of helpfulness reward model, which would be, hey, make sure I'm really good at extraction, make sure I'm really good at classification, make sure my data analysis and my math is really good when I'm doing a financial analysis, or make sure when I'm citing law, basically, I could be really good at that. And so there's kind of different actions. You can easily combine multiple reward models at the same time to do either data filtering for proper RLHF, stuff like that, basically.
So I do want to take us back a little bit earlier on in the post-training stage, because we've been talking a lot about fine-tuning and like ultimately we're using reward models because of some shortcomings in fine-tuning. And so just curious, just to get some more information from you, what shortfalls are there with fine-tuning and any cool research that you're working on to help address that?
Yeah, so from fine tuning, when you just do vanilla instruction fine tuning, you will honestly get pretty far. We've seen a lot of customer success stories at Databricks. We can, shift the distribution of these general language models to be better for your given task. But at some point, what fine tuning does is it just encourages the model to kind of respond. And so you're kind of teaching it to solely respond. And that means it can, in some ways, you can kind of encourage a little more hallucination. Sometimes it just kind of depends a little bit on the task. Again, it's science and it's a little hard to say precisely what happens with fine tuning. A lot of it does come down to data, what data are you feeding this thing, and just evaluating your downstream eval task. So again, depending on your task and your evals, depending on your task, your data and your evals, this will vary a lot. So being a little hand wavy here again, unfortunately, but that's the nature of the beast. But basically, one thing you can do instead of just vanilla fine tuning is kind of the full RLHF preference type of methods, basically. And what kind of this set of RL methods do compared to just vanilla fine tuning is it teaches the model to kind of say no or say, hey, these are bad responses. With vanilla fine tuning, it's very, very hard to teach the model like, hey, this is a bad response. With kind of an RL set of methods, so basically PPO, DPO, whatever policy optimization things that fall into RL, on Twitter you can see all the PO kind of things, fill in the XPO. Basically, those methods teach the thing to say, hey, this response is really good. This response is a high reward. But also it teaches us the model to say, hey, this is not a good response. So really what you're doing when you're applying RLHF to these models is you're trying to help the model surface the right answer. And what I mean by this is these language models basically have been trained on just internet scale data. If you do continue pre-training on these models, you can teach the model, hey, here's my company's documents, here's the company information, or you do RAG on these models. You say, hey, you RAG with these models, you say, hey, here's the retrieved documents, try to answer these questions. A lot of the knowledge is already there. What fine tuning does is help surface these answers a little bit and helps the model answer these questions. But then what RLHF really does, it helps really surface these answers, helps really say, hey, this is right and wrong, basically. And that's really hard to do with fine tuning directly.
And so how does all this fit into your work with soft or synthetic output fine tuning?
Yeah, so synthetic output fine tuning basically is one of these RL methods. At a very high level, what the customer does is they bring a prompt, and then what we do is we generate a lot from a model. For every prompt, you can generate a lot, and then you can basically apply this kind of these underlying RL methods to basically this prompt distribution, and it'll say, sorry, rewind really fast. So soft basically, you have your prompt set, you generate a lot, and then you basically use this reward model in a loop to basically make sure you're very, very good for these RL methods. And so the customer would just bring a set of prompts, and then we basically do this underlying RL process that allow you to do this optimization, this model fine tuning, that would make it so that one, you're surfacing the right responses effectively, but two, you're also making sure that the model kind of understands better what's a good response and what's a bad response. And so soft basically is a more powerful method than usually vanilla fine tuning or more powerful synthetic kind of data method that falls into kind of the RLHF umbrella. That basically was, as for preliminary benchmarks, we are seeing that it is a better version of fine tuning than just vanilla fine tuning. It's also simpler in the sense that a customer only needs to bring a set of prompts, and they don't need to bring this tricky set of golden prompt response pairs overall.
And what's the insight or the rationale behind generating multiple responses? Like, why not just generate like 2 responses?
Yeah, so with soft, basically what we do is for a customer's given a prompt set, we generate n responses, and is usually decently high. If you only generate 2, you're not inducing enough variance. So the model with only 2 responses, there might not be enough variance for us to pick up on. And this kind of goes into this new sequence of papers that have come out over time that say language models, no matter what size or capability, if you give them enough time to generate, they will have the ability to actually create the right answer. What you need to do is you need to be able to surface this answer. So specifically what I mean by this is basically you take your language model, you generate, let's say 16, 128,000 times, eventually you'll respond correctly. But then out of these responses, you then will probably have a lot of bad responses. And what happens is you can then use the good response, this thing that you can verify with a reward model, and the bad response, and use this for basically downstream fine tuning. That's kind of what the annoying pains of soft are. And why this is important for using, generating more versus generating, let's just say 2 responses, is because by generating more, you're giving the model more chances to actually generate the right answer, and then use the reward model to kind of say, hey, this is the right one and this is the wrong one, and try to surface the right one more often and the wrong one less often.
Cool. Okay, so we've been talking about soft, but I don't recall us actually defining what soft was. And so could you, or like the newbies version of it. So I should rephrase it that way. Sorry, because you've explained what soft is. I'm sorry, but what exactly is soft per se? Like, what does it represent? Is it an acronym of some type?
Yeah, sorry. So the newbies version basically it's an internal Databricks research product that we are opening up to basically Databricks customers for basically a research kind of product preview. What this kind of looks like is it's an outcome from the research team, and it's a new alternative kind of fine tuning. What the customer again brings is they just bring prompts, and so all you need to do is say, hey, here are the set of inputs that I want the model to be really good at generating responses for. And then what we do is we run this underlying soft process where you generate a lot. You generate, let's say, 16, 128 times, however many times. And then what we do is use the reward model to kind of say, hey, here's a good response. Hey, here's a bad response, or basically rank all these responses. From there, we can apply basically these RLHF kind of methods under the hood for the customer and say, hey, here is now your new fine-tuned model overall. And this will be basically hopefully really good on your distribution of prompts you just gave us.
Oh, got it. Okay, so is this process basically there to make up for the fact of like the lack of data in essence, like that you're actually in essence generating more, I guess like synthetic output? I guess that's the context.
Exactly, yeah. So soft is a synthetic output, basically data. It leverages a lot of synthetic data, basically, and that's
Oh,
just
got it.
because again, yeah, a lot of basically a lot of the prompt response pairs of, hey, for fine tuning, you actually need to bring the prompt response pairs to the table doesn't really exist, and so this is kind of the key. This is kind of what soft tries to solve. It says, hey, you don't need to really bring this prompt response pair, which again this doesn't really exist in the wild. It's very hard to actually find this in the wild. You only really need to bring say, hey, I want this language model to be really good at either extracting this data, writing the SQL query, writing this code for me. And so that's kind of what the customer brings to the table for soft.
And when you generate multiple responses, is it just adjusting the temperature of one model or using multiple models to be able to generate that variability across responses?
Yeah, under the hood right now, it's just one model. But again, to induce more variance, it is very possible, and this, again, open research question, to use different models. You could use different size llamas, different size general models, stuff like that, to induce a little more variance such that you're actually covering this kind of generative space a little better. But again, open research question there.
Got it. And since you mentioned Llama, I know in at least the Llama 2 paper, it talked about all the reward modeling that went into it and like the relatively limited fine tuning. So curious if you could dive a bit more into like the post training that the Llama models underwent.
Yeah, so I think a big part of the Llama 2 and 3 papers basically talk about, for post training, one, understanding data quality a lot, and then two, kind of some of the methodologies. So on the data quality side of things, there's a lot of extensive work on understanding, hey, what is a good prompt basically? Is this prompt too easy? Is this prompt too hard? Is it underspecified? And filtering out kind of your prompt sets. This is actually really important to make sure for post training, you're only training on high quality data. The other side of post training always is kind of the model response pairs. So again, when you kind of just start with, let's say, fine tuning, you have this prompt response pair. You always want to make sure your the response side of the prompt response pair is also good. I think earlier in this talk, we basically talked about how to make sure we get this good response pair. In the Llama 2 paper and Llama 3 paper, they discussed this thing called rejection sampling, where they use the reward model to kind of filter out the model generations. So again, once you have this high quality prompt, you can overgenerate. You can generate, let's say, 16 times, and then say, use your reward model to rank all 16 responses and say, okay, now like this response 3 was the best. Therefore, let's only fine tune our response 3, for example. Um, that's actually, again, very important to make sure we're only training on the highest quality prompt response pairs. Um, then on the kind of that's kind of covering a lot of the post training. Let's only train on high quality data side, right? So if you train on, let's say, low quality data, you're gonna get to the machine learning garbage in, garbage out kind of thing, where you say, hey, my prompts are underspecified, my generations are not great. You shouldn't expect your model to do super well. So again, in post training, data quality is something that really, really matters. Then on the kind of method side, both Llama 2 and Llama 3 kind of discuss different types of things beyond just vanilla fine tuning. So for example, Llama 2 use a lot of policy proximal optimization, or PPO, which is again a very common method in the RLHF pipeline. And then Llama 3 and 3.1 use a lot of DPO, which is direct preference optimization, and also PPO. So basically, this is kind of the RLHF type of algorithms that basically will say, one, let's make sure the model can surface the knowledge correctly. Then two, let's make sure that the model doesn't actually, it teaches the model to not say things basically. So that again could be incorrect math traces. It could be on the Hugo says incorrect math traces, incorrect reasoning traces, stuff like that. Or on the safety side, it could be, let's say, for the enterprise use cases, it'd be, let's not talk about competitors. Let's make sure we, keep HR compliant. Let's make sure we keep to certain company guidelines depending on the internal company guidelines. That's kind of the generic RLHF usage of on the capability side, making sure we're saying the right things, but also making sure we're keeping compliant to saying, hey, you don't want to say these certain things. So overall, it's kind of covering both the data quality side and also the method side for Llama 2 and Llama 3 at a very quick, 10,000 foot overview.
Sorry, I just really had to ask. You mentioned process techniques, DPO and PPO. Sorry, could you do the explain like I'm five versions of those?
Denny, I don't think a 5-year-old's going to need those. Maybe 12-year-old?
Oh, yeah, fair enough. Sorry, my bad. 12-year-old. Explain I'm 12. Sorry. Yeah.
Totally, yeah. So DPO basically, let's start with PPO first really quick. So PPO basically, it's usually done in just reinforcement learning in RL. And what you do in the RLHF side of things is, again, you just bring a set of prompts. And what you do is you say, over time, you have your language model first generate things. You have a reward model that you've trained already to kind of score this response. And then you use basically this underlying RL, just RL math that says, hey, let's maximize the reward. So it's uses, a few more models. It's a little more complicated setup. There's a lot of complexities here. And basically what it says is on your prompt distribution, let's maximize the reward over time. Maximize the reward of this external reward model. DPO is an alternative to PPO. Usually what you do for DPO is you already have this preference set. So it's very similar to reward models, but basically what you have is you have a prompt and then you have a chosen or rejected. So again, it's the side by side, hey, A is better or B is better. And what you do in this case is DPO basically in a similar vein says, let's make sure that the chosen response is more likely generated than the rejected response. Essentially what this is implicitly saying is, let's make sure we surface the chosen thing more and the rejected thing less. And so this implicitly does something kind of like PPO, but you already have this kind of offline data set, and that's what kind of usually brings to the table for a DPO.
Got it. Okay. Then I'm, again, maybe explain like I'm 12. Couldn't we get an AI to basically do the, to actually monitor this stuff, or does it require humans to actually really help with that entire process? Can't an AI get involved with this? I realize it's sort of meta, but yeah. No pun intended.
Yeah.
Really no pun intended.
Totally. No, yeah. So in this case, right, usually when people talk about RLHF, you have, I'd be a human, I would say, hey, A or B is better. But there's a lot of work that goes into saying, hey, these language models are very general. Let's have them give feedback in this space and say, hey, because I've been trained on so many things, I kind of know how to model language well. I can say this A thing is better, this B thing is better. And so this is kind of called RLAIF. So you're running from AI feedback. And so again, you can implicitly say in the DPO case, hey, label from these two responses, which one is better, A or B? In a similar vein, for kind of the soft stuff that we've been talking about earlier, basically you can use this reward model to say, hey, this thing, A or B is better.
Cool. That's a really interesting. Thanks for explaining that.
I don't know. I personally just have reservations, I guess, about not having a human in the loop for some of these things. I'm just curious to get your thoughts on that, Brandon.
Yeah, so I think overall, there's always going to be some need for human in the loop, some human supervision. This is always just kind of saying, hey, when you run evals, we want to make sure that the evals are sensible, the eval makes sense. In a similar vein, when you are training these models, you can always go look at your data and say, does this kind of data make sense for it to be better or worse? Also in a similar vein, for example, as you filter out prompts, as you say, I want to train on this high quality data. There's always going to be these weird kind of holes that exist in language models just because by nature of kind of how they work, there's going to be some holes. So you do need some human supervision to say, hey, maybe this prompt is actually kind of good. And you kind of pull levers over time as a human to kind of understand where these pain points are in terms of the eval space, in terms of the data space, in terms of where you're optimizing. And so I think overall, there's always going to be this kind of need for human in the loop a little bit. And then beyond that also, even to do some of this AI feedback stuff, usually the canonical thing is you need some human input to kind of start this kind of process of synthetic data of monitoring all these things. And so again, the human part for all these, even just general fine-tuning of preference optimization, is the humans providing the prompts. That is saying, what tasks do I even care about in the first place? What data do I kind of want to learn about? Stuff like that. And that's always going to be kind of this human understanding, human supervision that will always be needed overall.
Awesome. And I know we've been talking about data, but I'm really curious to get your thoughts into, like, for pre-training, we're talking about billions or trillions of tokens. For instruction fine-tuning, we're talking about like thousands to tens of thousands examples. For reward models, how much data do you actually need to be able to build a reward model?
Yeah, it's a really good question. I think building one from scratch, usually the canonical thing is you can start to see a little bit of signal around, like, I'd say 10K or so preference samples. But again, because there's already a lot of work that has been done on reward modeling, it's a bit of an open research question of how many you need to bring in this case if you want to, say, let's say, fine-tune a reward model. From that, I'd be a little less comfortable with giving an exact number. But if you're just saying, let's say, training one from scratch, around 10K, you can start to see some signal of like, hey, this model kind of understands what is better and worse.
Awesome. And yeah, I totally cognizant of the fact this is open research. And actually, on that topic, what are some of the trends that you're seeing within the field of reward models? Like, what's some exciting research that people should be on the lookout for?
Yeah, I think there's kind of two main things right now. So the first basically is uh, usually reward models. What I said earlier in the talk was basically, hey, reward models are really good at ranking these entire generations. So basically, this means that for a given prompt, you say, hey, reward model, which one of these entire generations is the best? The issue is that means if there's some intermediate steps, let's say in the middle of some chain of thought or in the middle of some little extraction thing, the generation is actually bad. Usually these kind of holistic reward models, so these things that rank entire generations, they kind of implicitly somehow know that this generation is bad, but they can't actually pinpoint where in the generation is bad. There's this work that's been going around a little bit. We've done this bit at Databricks called fine-grained reward models. Externally, they're calling it process-based reward models. But basically what this says is now on the kind of span or like on the intermediate sequence level, you can say, hey, your JSON is malformed here, or hey, your analysis is bad here, or hey, this chain of thought is kind of bad. That's actually really powerful because then you can kind of identify on this more granular level which parts are bad. So that's kind of one part of reward models that are that's very interesting research right now. I think two, there's also this kind of research on saying, hey, how do we generate new data for reward models? This is kind of all the RLHF stuff and different methods into creating new sets of preference data that is cheaper. Again, is much cheaper than having, let's say you sit in front of a user screen and say, hey, which one is better, A or B? So this is kind of into the RLHF space of saying, hey, how do we generate new preference data that actually improves our reward model on the task distribution we care about? How do we make new preference data, make the reward models better, stuff like that.
Yeah, I see a lot of applications of fine-grained reward models because it's instead of like, is the entire generated response correct or not, it's which portion of it is the portion that needs to be corrected, because oftentimes these responses are quite lengthy.
Exactly.
And it might be 90% accurate overall, but there's just a few key things that are a little bit off.
Exactly, yeah. So I think actually in the fine-grained reward model paper came out of one of the research here at Databricks, basically they use these fine-grained rewards on something like functionality. So for example, the diagram they think they use there is they train a reward model to actually be explicitly good on the factual side of things. So it could highlight basically a span that says, for example, very contrived example, oh, the capital of France is London. And they would basically say, oh, London is actually incorrect. It should be Paris. And the rule can actually kind of flag this thing and say, hey, actually, this is actually a factually incorrect response.
Awesome. Well, thank you for providing some tips and pointers, and we'll also link that blog in the podcast. And thank you again for joining us in such a enlightening conversation on reward models today, Brandon.
Awesome. Thanks, guys. Appreciate it a lot. Thank you for having me.